Hi guys, my name is Monroe King. I'm captain of Team Prometheus, and wanted to give you a nickel tour of what we've been up to lately. Uh, Thanks to funding from people like Timothy Leard and Elliot Kaleko, and lots of help from all kinds of other people. We have built a shop out of a couple of 40-foot high cube confabs or containers, and I'd like to show you all that, but this is the nickel tour. So uh, we got this Bridgeport, which is a 2 horsepower, speed spindle, 42 or 48 inch. I'm not sure on the table. These things were totally in bad shape when we first got them, and I disassembled them, painted them back up, hand scraped the ways, and the table here is within a 1,000ths from one end to the other. Over here we've got the South Bend Heavy 10. This is a 1947 model, by the way, but and it was in equally bad shape. But after a lot of hand scraping, a lot of bearing adjustments, and some specially made parts, this thing works great now. We've got a bandsaw and a blade welder over here, 20 inch. And let's see. Down here we've got a nice 250 amp TIG welder plasma cutter. Outside we've got a large Miller water cooled TIG welder, 300 amp. We've been working on projects like this. This is the X12A, which I'll show you some more about here in a minute. It's a rocket-powered glider that we wanted to drop from an altitude of 30 kilometers or 100,000 plus feet. I've been working with do-it-yourself drones for like 8 years now, and 3D Robotics has been good at sponsoring us with autopilots, and I'll show you some more about that here in a bit. This is a 170,000 cubic foot zero pressure balloon, which we've been trying to get it's big enough to carry this rocket motor, which is pretty large. This is our Q impulse rocket booster, and it's 96 inches tall, 8-inch diameter, I believe. See if I can get this end out. This is the igniter end, and here you put a small rocket motor to ignite the larger rocket motor. Fits right in there. Run the igniter up through the rocket motor. This is the nozzle for the small igniter motor. This one's been static fired 4 times and flown twice. It's got a nozzle. As you can see, it's been fired. A little bit of erosion here on the graphite. Not too bad. I'll tell you some more about that in a minute. This is a Q impulse. Latest project that we're working on is this 5-axis CNC machine. The reason for the 5-axis machine is to make impellers like this one right here for testing turbo pumps. This is a turbine off a car, but it's very similar to a turbo pump turbine. But it moved. This is a special design because it's not a moving gantry; it's a moving table, and that's about as far as we are in it right now. The x-axis and the y-axis are working. You still have to. There's still a lot of machine work to be done for the Z, and then we're gonna have the trunnion table for the two other axes. Trunnion table. Got another lathe here that still needs to be worked on. I'll give you a quick look at the electronics area. It's kind of messy, so you have to forget the mess. This is a quickie nickel tour. This is a LaCroix 9400A with FFT option and averaging that I rebuilt. Hewlett Packard 16500A logic analyzer and oscilloscope. Let's see. Yeah, and it's working good. This is the only piece that I hadn't had to repair. Just a little bit of minor stuff with the touchscreen. This is just a standard. This is just 25 megahertz analog scope for doing all kinds of little stuff, which I had to repair, by the way. And I also bought a couple of these Fluke. It's an older model. Yeah, it's 8800A. The reason I got this one is because it has the Kelvin clamp for sensing with higher accuracy. This is about as accurate as you can get for an older type machine. I've got a Kenwood TS44S over here, transceiver, ham radio, and a 2-meter ICOM, and a 2-meter combination handheld. And I use this to pick up satellites. There's a whole lot I can tell you about that. I'm working with some guys, SatNogs, trying to set up a amateur satellite listening network so that once we do get some CubeSats and things into orbit, we can track them without the need of NASA or any. I have to pay a lot of money for it. Anyway, this is just a quick and dirty. Here's some. These are the RG pilots, which I'll show you something about them here in a minute. I get a lot of guff because I think I know that these can work for guidance for rockets, and I know there's a couple of things that need to be done to make them work as that, but I'm not going to go into them because if you know what you're doing, you can do it yourself. Let's see. Anyway, I've got some power supplies and another power supply for the ham radio gear, a signal generator. I use software-defined radio for picking up satellites, and I use that in here. Let me go back over here. Let's show you something real quick on the main computer. I'll show you the. Oh, there you go. Bang it around. This is a really nice old TX X1000R. that I got as a basket case, which, man, you do not want to mess with one of these if you don't know what you're doing. It's not blinking. Tape monitor. There you go. It's a recording. It's an actual recording from a studio in somewhere up north, like Wisconsin, back in the '80s. But thought that was kind of cool. This is those are Panasonic quadraphonic receivers that I repaired. Using both of these, I've got 7.1. I've got a big subwoofer down there. Sometimes we kick back and watch movies in THX. And that is an 8-track player there too, just for fun. Okay, show you some things here. This is a flight from 100,000 feet with a glider, an unpowered glider that we did a few years ago and flew back. This is my favorite cartoon, Resources of Space, and it's the whole continent. And then over here it says Earth, which is out in the little, kind of like that one movie. Can't think of the name of it. And this is a little boat with space program on it. It says, "We can't afford these expensive expeditions. We have enough problems right here on Earth." So I always thought that was really hilarious. This is a part we made for Richard Naka and Sugar Shot to Space, which I've done a lot of work for lots of other programs. And this one is interesting because Richard Naka designed some really, really intricate and really refined components for his rockets. And I have to say that this thing is paper thin, it's very lightweight, and it was a lot of fun to make, actually. This is a shot from a TV show we did for a G4 station. The show's name was Effin' Science, and we sent a dummy up for the show, and that's one of the stars of the show there. There she is there, and these are the other two guys that are in the show. We went up there and helped them launch that. It's one of the few projects we actually made any money on. This is another part for Sugar Shot to Space, Richard Naka. This is ArduSat, which is, we helped them with Kickstarter raise over $170,000, and they actually succeeded at putting their CubeSat in orbit. They came by, Joel Spark and Jerome, and they were in the shop doing programming, and they helped build a tracking satellite antenna, which I'll show you in a second. This is that X12A that I just showed you a while ago. The guys at These Sky Labs helped us do a simulation for all of our rockets and balloons and everything that we do. We track them with, and we use flight gear and X-plane to do the simulation in real time. And we also use them to do simulations, of course, for design. I also use SolidWorks Premium, which has CFD and FEA for a. Of course, it's not premium, but it's what we have to use. This is a simulation of the X12A, which we want to carry the X-12A on top of the Q as a booster stage, and this is a rocket-powered glider, the X-12A, which I'll show you some more of. Okay. Yeah, that's the X-12A, which is the same exact size as the. No, this is like X-11E, and Chris Cohortis, which is the designer, was the designer of that, and he's launching it right there. He shared his design with us, and that's a SolidWorks drawing of it. This is some work done by a fellow named Kabir that helped us with the autopilot, because the autopilot's frame of reference is not the same as the frame of reference that you need in space. So he wrote some programming for the PX4, which is pretty much the same thing as the Pixhawk, which is what we're currently using for a guidance system. This is reaction wheels on a CubeSat, but the same program works for reaction control system, which is what we needed with the X-12A, because when you're outside the atmosphere, you don't have atmosphere, of course, to fly in, so you have to have a reaction control system. This is a balloon launch that we did a while back. This is a project I worked on a long time ago. This is the Bloodhound rocket car engine. This is a static test. What I did for Jerry Irvine was I designed a manifold and pressure system to pressurize this peroxide tank, and also designed some data acquisition equipment for the test stand. The stuff that I designed never got implemented because the project ran out of money, and long story short. But here's what the test looked like, which was kind of cool. Hope I don't have the volume too loud. I have any volume at all. Yeah, it's there. You just can't hear it. Anyway, it's an 18-inch diameter hybrid rocket. I get you a chunk of the fuel here somewhere. Have a chunk of rocket fuel from that. Anyway, I don't know where it is. It's about a 5-gallon bucket size worth. Anyway, the cool thing about this one was that the fuel was standard hybrid rocket propellant, which is just the rubber from the APCP type engine motor. The trick was 5% AP, ammonium perchlorate, was added, which helped it burn a lot faster and get better performance. Anyway, this also had a pump and a 20,000 RPM Formula One engine, and it had been sitting there for like a year. And I told them, this Formula One engine can't be started. I mean, if you've got a Formula One engine, they have to be turned over within 3 months, or the valve springs go bad, things like that. So anyway, at that point, it really didn't matter much. Okay. This is a design for a Barsky impeller for a turbo pump. This is me at another balloon launch. I designed that insignia, and that took a long time, like 3 months. This is one we did from another I've got that one over here. Ugh. This is that same plane. It's kind of decrepit now, but a long time ago we flew that 200,000 feet, dropped it, flew it back. And this is actually FPV view, which I'm not going to go into how we did that. That's just, this is the nickel tour. There's a photo from one of the balloon launches that we did a panorama with. It had 6 GoPro cameras on it, and that's the balloon burst at 100,000 or better. This is a render of one of the pump designs that I'm working on that president of CTI did a render in 3D for 3D print render for us. Anthony Cicerone did that. This is a render that of the same one in aluminum that he owns Armadillo Aerospace now. Russell Blink did that for this project that I started on A-Rock. This is the Q motor launch. That is the tracking antenna that Joel Spark and guys from NanoSatisfy worked on with Argisat. That's my ship in the Navy, USS Antietam, CG-54. Guided missile cruiser. Another shot from a balloon. Another drawings of turbo pump. This is that's the X11E. Did I miss anything? Yes, I missed the rocket launch of the. That's the Q rocket launch. I don't know why my sound's not working. But anyway, you get the gist of that. It was really loud. And you know, okay. Here's our website. That's a photo we took, one of the very first ones from over 100,000 feet. That right there is Jeff Jacobs, and this guy is Rick Maschek. That's me. This is Jeff Jacobs' R10,000 hybrid, which I didn't work on, but I was hanging out with these guys at the time. Got a Facebook page. A lot of this started off with LDR 29 photos of some of the stuff we've done. I've already shown you. Oh, that one. Different angle of it, anyway. Nope. Okay. On to other things. Oh, I don't have a picture of this one. Oh, I've got a bunch of pictures of the aftermath of the test of the Bloodhound rocket car and things like that. Some interesting things happened, like the cat pack sort of collapsed a little bit. Did burn all the fuel. It was actually really interesting. This is Raccoon, which is what we launched. We may have an altitude record for this. I don't know, but this reached 225,000 feet. Uh, GoPro, lots of electronics, another camera. That was really cool. That's from the Raccoon launch on the way down. That's the best video, best photo we got. Oh, Team Frednet, Google Lunar X Prize. We built a mock-up of their lander for them, and it was to be a powered one. After putting in the money to build the lander mock-up, we couldn't afford the propellant. So, and we never progressed any farther on that one. So that's as far as we got with that. Sugar Shot Space. Hard to set. Oh, this we got third prize on Open Rocket for collaboration with a bunch of other guys, and this was a interesting hybrid rocket design. It's got 4 sides. Okay. You can look at the teamprometheus.org website. Oh, this is the shear that's sitting right outside here. This thing weighs 17,000 pounds, but we got this shear to make stainless steel tanks. Stainless steel tanks for when we start testing this particular rocket impeller is for hydrogen peroxide and kerosene. But we got that shear. We need a pinch roll, and I'm building a lathe, a very long lathe, I-beams, so that I can set up some automated TIG welding for it. Anyway, I think that catches you up with for the nickel tour. Anyway, hope you enjoyed it, and hope to see you out there.